Cracks of the Earth's surface and even man-made structures are always under attack by physical and chemical forces. There is physical weathering and chemical weathering. Physical weathering, sometimes called mechanical weathering, is literally the cracking, breaking up, and grinding down of rocks and other objects. There are different causes of physical weathering. It might surprise you to know that temperature changes are one of the most powerful forces of physical weathering. And that's especially true for rapid or extreme changes in temperature. As you know, heat makes things expand and cold makes them contract. Rapid or uneven expansion can do a lot of damage.
You mean like if someone took an ice cold mug and then poured hot coffee into it?
Yep, it would be a shattering experience.
Yeah, and the mug didn't do too well either.
The extreme heat from forest fires can cause rocks to crack. And every day, rocks that have been chilled by the cold night air are warmed by the sunlight of the day. The outer layers of rock warm faster than the inner layers. This can cause cracking and flaking of the rock. The same thing happens in reverse as the outer layers of rock cool again at night. Cold temperatures also cause another problem for rocks. Water from rain, snow, or dew can get into the cracks in rocks. When temperatures drop at night, this water can freeze and in turn expand. This can force the cracks in the rocks to enlarge and sometimes splits the rocks wide open.
If I was a rock, I'd be afraid to sleep at night.
Rocks don't.
Joking, Captain. Just joking.
Physical weathering can also be caused by the actions of living things, organic activity, animals and plants, for instance.
How can animals and plants harm rocks?
On Earth, animals do most of their damage to rocks by digging. Some rocks are soft enough to be scratched away slowly, but more often than not, the animals dig holes in the soil near rocks. This gives air and water and temperature changes more access to rocks and can cause uneven support, leading to cracking. It can also cause rocks to topple and roll down slopes. Would you believe that plants are even more likely to break up rocks?
I'm not buying that. Plants don't move.
Well, while that's true, plants do cause weathering. The roots of plants can be incredibly strong. When the tip of a root gets into a crack in a rock, it can enlarge the crack as it grows. You can see this sort of thing happening as trees lift and break apart sidewalks and roads. The force of gravity can cause rocks to fall or roll down slopes where they can break themselves apart and shatter other rocks. A powerful example of this occurred at Yosemite National Park in California, when a massive rock slide began as giant slabs of granite broke off from a cliff face and smashed into the rocks and earth below. The final force of physical weathering is abrasion, or grinding away.
Like from a sandstorm.
Yes, wind-blown sand can be very destructive. Over thousands of years, it can wear rocks down to nothing or carve them into some very interesting shapes. Abrasion also happens when rocks grind together as water moves them. This is constantly seen in rivers and along ocean shorelines. It's the reason small rocks found in these locations are rounded, and one of the reasons bigger rocks seem to have been carved and polished. Those are the causes of physical weathering: temperature, ice, organic activity, gravity, and abrasion. Now let's take a look at chemical weathering. We'll start with the liquid that's the main cause of chemical weathering on the Earth: water.
Huh? Water? But water is the basis for life on Earth. How could it be destructive?
Water will dissolve more things than any other substance on Earth, even though it sometimes takes a very long time.
It will even dissolve rocks?
Water will dissolve the minerals that hold some rocks together. When this happens, the rocks begin to crumble. Look at these odd rock formations. They were formed because the rocks that capped them didn't dissolve in rainwater as fast as the rocks that made up the pillars. As the rain slowly dissolved away all the surrounding rock, the cap rocks acted like umbrellas. shelters. Over many years, exposure to the weather can damage the marble rock used in sculptures. Look at this old statue and these tombstones.
Those tombstones will soon need their own tombstones.
Water can also combine with certain gases in the air to form acids. This is especially true in modern times when the pollution generated by burning fossil fuels releases large amounts of sulfur compounds into the air. Water vapor and rain combine with this chemical to form weak sulfuric acid. This is where the term acid rain comes from. Acid rain not only weathers rocks, it destroys man-made structures and kills forests and fish. Carbon dioxide is present in the air in large amounts. When carbon dioxide combines with water, it forms carbonic acid. This is called carbonation. This weak acid can still dissolve some minerals, especially calcium. It will dissolve limestone completely. This is how many underground caverns are formed. The limestone is literally dissolved away.
Are there any other kinds of acids that weather rocks?
Surprisingly, some plants create weak acids. Those crusty things often seen growing on rocks are called lichens. Lichens create weak acid, which causes chemical weathering, while the tiny roots of lichens break up rock surfaces through physical weathering. Let's see if you can guess what the final agent of chemical weathering is. It's another one you probably wouldn't expect.
Well, the first one was simple water. So, I don't know. How about air?
Correct. The oxygen in air, to be exact. The oxygen often combines with minerals or elements in rocks and changes them into other compounds, which weaken the original rock. This is called oxidation. One of the most common of these reactions happens when iron combines with oxygen to form reddish iron oxide, known as rust, which you see in the red rocks here.
5 forces of physical weathering. And now, 5 causes of chemical weathering. Water, sulfuric acid, carbonation, plant acids, and oxidation.
And remember, chemical and physical weathering are often at work at the same time.